Hey, in number 7, they ask us to rewrite this formula so that h is isolated. This is the formula used to find the area of a trapezoid. Interesting discussion about, where this formula comes from, how do we derive it. But that's not the point of this question. The question is just take it and transform it using properties of equality so that h is by itself. One of the things that I really like to do whenever I see fractions, I will often do this trick. I'm going to multiply both sides by the number 2. And the reason why I'm choosing to multiply by 2 is because if I multiply 2 and 1/2, I get the number 1. A number times its reciprocal equals 1. Now, occasionally I see students that get really kind of confused by this because they're so used to thinking about the distributive property that they think this value 2 needs to go to several things. Look inside of the parentheses I've marked with green. There's 3 things here, right? And they are all factors. Right? One of the factors inside the parentheses is 1/2. The other factors inside the parentheses is this green bubble, right? This green bubble right there, which is base 1 plus base 2, the sum of the two bases. And the final thing inside of there is this factor h. So although it's a little bit more complex, there are 1, 2, 3 things inside of there. And it's kind of like if I had the number 3 times 2 times 10, and I wanted to come along and multiply that by another value, like 2, right? I wouldn't be multiplying each one of those by 2 because that would be equivalent to multiplying this thing by 8. I'm only going to multiply, just the one of them, and it doesn't matter which one of them by 2. Maybe even a little bit a simpler example to help you kind of convince yourself this is true. And I love doing this, is just kind of like, hey, what if I have the number 3 and I multiply that by 2 times 3? Well, 2 times 3 is pretty simple. That's the number 6. And if I multiply 6 times 3, that's equal to 18. So I know this equals 18. Now, if I come along and I'm like careless and I'm not thinking about it, and I multiply both the 2 and the 3 by this outside 3, right? If I was to do that, all of a sudden it would be actually 3 times bigger than 18, right? We do not distribute multiplication, this way. We can choose to distribute multiplication across addition, right? If we want, this is equivalent to 3 times 2 plus 3 times 3. The problem that I see is a lot of times we kind of overgeneralize. We'll see these and just get carried away with this nifty trick that we think we learned called the distributive property. Anyways, I'm multiplying both sides of this equation by 2 just for the simple fact that I know that 2 times 1/2 is going to equal the number 1. That will equal 1. So let's rewrite this the next step, and I'll go back to this handy red pen. So now what I have is I have 2a, and that equals parentheses base 1 plus base 2 times the height. Now, again, really difficult to see, what's going on here, but it's a chunk, right? It's a hunk of math that's encapsulated inside of these beautiful parentheses. And if I pull it back and I just squint, just so it's just a tiny little thing. Well, not quite. But you can almost imagine that what you have here is just something, I don't know what it is, something times, for example, x, If I wanted to get h alone in this situation, I would divide both sides of the equation by x because common factors, can be canceled. So when I look at this, back over here to our problem, you can see I've got this chunk and I'm going to divide both sides exactly by that chunk. When I do that, the chunk is base 1 plus base 2. It's the sum of my bases. And I'm going to do that to both sides of this equation. Although I got a little carried away there. Both sides of this equation. Base 1 plus base 2. And again, if I look at the right-hand side here, there's this huge chunk, right? This is all encapsulated as one thing over one thing. So what I've done now is I've very conveniently gotten h completely alone. This is isolated. And I can rewrite this now. I know that the height equals, and I'm just flipping it here, on the other side, the height is equal to what? Well, the height is equal to 2 times the area divided by the sum of the bases, base 1 plus base 2. That's number 7.